morning, everyone, or good day, depending on where you are in the world. Thank you for joining us at the Rise of Privacy Tech Virtual Summit. This session is going to cover zero-knowledge proofs and other privacy types of developments in the blockchain and crypto space. I'm really excited to have Rhian Lewis, who's the author of the Cryptocurrency Revolution and who's also a developer, and John, right, if I'm saying it correctly, who is the co-founder of Enigma. I caught myself just the last second there. Just a reminder, this is supposed to be interactive, so if folks have questions, please feel free to type them, or you can request to come up and turn on your camera and talk to us if you have other questions that you wanna bring up. But other than that, I'm gonna kick it off to both John and Rhian if they want to add to their intros and say hello to everyone.
Hi, really happy to be joining everyone. It's good evening here because I'm on the southwest coast of the UK. I don't have much to add to the intro. I'm a developer and author, been active in the crypto space for the last 7 or 8 years, and it's a huge passion for me.
Hi everyone, my name is John. I am a co-founder of a company called Enigma. At Enigma, we're building an open source privacy-preserving blockchain platform called Secret Network, and I lead product initiatives both for Enigma and the Secret Network developer ecosystem at large. Similarly, I've been in crypto since I would say 2014, I consider myself very lucky to be working in this industry and in this new version of what internet may become.
Thank you both, and welcome to the Rise of Privacy Tech. And we try to bring together people who are trying to solve for privacy problems. And in addition to the compliance stuff that we talked about earlier and some of the privacy engineering tools that are popping up, we noticed that there are more and more crypto blockchain solutions that in the space, and that they are also, many of the founders and developers are talking about solving for privacy problems in these use cases. And so I'm really trying to scratch my itch here when I put together this panel, especially given the interest and the development when it comes to zero knowledge proofs. So as we know, zero knowledge proofs, unlike blockchain, it's not a new thing. It's been in existence since the 1980s. But I want us to kind of maybe set up the discussion. So to Rhian, if you don't mind, how do you explain zero knowledge proofs to maybe an 8-year-old?
Well, I'm glad you said to like an 8-year-old, because I think that the easiest way to understand the concept is via a real life scenario that everybody is familiar with, rather than getting into the technical specifics straight away. So imagine you're not an 8-year-old maybe, but maybe a somebody wanting to buy a home, and say you go to a financial advisor and you want to find out what type of how much you can borrow, but you don't want to disclose to this advisor exactly what your income is. You just want to prove that you earn enough to be able to make the repayments. So the very kind of analog example, not going near any smart contracts or kind of validations or whatever, would be going into a room. The advisor has access to a whole load of boxes, and they put different amounts on the outside of the boxes, and then the keys to all the boxes are destroyed except the one which contains the threshold at which the personal people become eligible for the loan. And then the people who want to take out the loan can go in and they can put a tick or a cross in a little hole in each of the boxes. So when the advisor comes back into the room and unlocks the one box, they can just see a cross or a tick to show whether the person has an income below or above the threshold. they cannot open any of the other boxes to see exactly the amount that that person earns each year. So it's quite a neat example to show that you haven't had to give away a lot of information that you don't want to disclose, all your banking account details, all your employment details. You just have this, I can afford it, yes or no.
Thank you for that, Rhian. And you're absolutely right. It's an excellent example to describe zero-knowledge proofs, which is a cryptographic method that allows, in your example, one party, the prover, to prove to another, the verifier, that they know a statement to be true without disclosing additional information. So thank you for illustrating that for us. John, I'm curious, what are ZKP's main elements? Like in practice, what are some of the rules that ZKP follows? Like if you were to describe it further and take the definition further, what are some of these main elements that ZKP encompasses?
I mean, so zero knowledge proof, as Rhian mentioned, allows someone to prove that they know something to the other party, without really letting the other party know what they know, right? This could be age, this could be income, as we discussed in the previous example. And I think there are two processes. I think if one is the process of creating a proof, and then the process of verifying the proof. And obviously the proof is generated by the person who has information. So say, for example, Alice is trying to prove to Bob that she's over 21, but she does not want to disclose her age. So what Alice does is Alice generates the proof. This is usually the computationally expensive process. And then when Alice shares that proof with Bob, Bob can verify that Alice is indeed over 21 years old.
Thank you for that. I'm curious. So I want to bring these two together, right? We had a blockchain privacy session earlier. Some of the challenges that regulators have raised when it came to blockchains, I was in an FTC workshop maybe 5 years ago, was the immutability, the immutable nature of blockchain and decentralized tech in general. And so there are some challenges when it comes to privacy with that, because once you save data on the blockchain and it's immutable, you're unable to delete it. And all these laws, the privacy data protection laws, say that an individual has a right to delete their data. Europe has come up with that right in a case against Google, the right to be forgotten, the right to delete. So, John, why is ZKP gaining traction in blockchain? I'm also, as additional background, I was particularly fascinated when the Ethereum co-founder Vitalik Buterin and Naval Ravikant, who's one of the big angel investors in the crypto space, were really hyping up ZKP's role in blockchain when it comes to privacy. I'm curious what you think about this and why you think this is gaining traction in the blockchain and crypto space.
I mean, at the moment, the main use case for zero knowledge proof, for like Stark, which is a family of Starks and Snarks, which are both a family of zero knowledge proof, is primarily for scaling, not as much for privacy. And the idea is, on a public blockchain like Ethereum, every transaction needs to be processed by every node, and that's how, or the miners, and that's how people get to consensus. And this is an expensive process. A way to, and that's what we call Ethereum scalability problem, that, it gets expensive to do transactions and, you have to wait. And a way to address that issue with zero knowledge is having, an off-chain operator similar to the web servers that we're aware of, do all these computations, and create a zero knowledge proof that the transactions that took place off-chain are indeed accurate. And when the main chain gets that message, then the main chain can say, okay, like these 100 things happened off-chain, and I can verify that these things happened based on the proof that was sent to me. And this has been explored in use cases like trading on Ethereum. So that's really the main use case right now that I see, or like not the main, but the most advanced use case that there is for zero knowledge proof. There's also certain smart contracting platforms that use zero knowledge proofs to write private contracts.
Right.
You know, one example of that is Aztec. And if anyone's interested, for the previous example I gave, Starkware is a leading company that does that. They did, I think they did a collaboration of DY on the zero knowledge proof for smart contracts. Aztec, company that's doing that. There's some other companies that recently initially create transactions in a private way on a side chain, and then they're hoping to add new functionality going forwards.
Thank you for that, John. And certainly scalability is one of those problems. Rhian, what are some of the privacy problems that you see ZKP solve for on the blockchain, if anything comes to mind?
Yeah, I think there is quite a lot really, because in terms of the institutions that we now see coming into the space, particularly in terms of institutions and high net worth individuals starting to dabble in the DeFi area particularly, I think there are lots of problems that can occur with people front running, or people not wanting to disclose certain things about their transactions. So it's, you know, we all know the advantages of public blockchains are immense and valuable. Their transparency is in most cases a feature, not a bug. But in terms of institutions who are used to not having this information in the public domain,
Accountability.
Exactly, it can be a real problem. And then also, as I said, we in terms even of Vitalik Buterin himself, when recently he gave all his meme coins to charity, and the price then crashed because there was a perception that that big dump going on, but people could see that happening. I'm not saying that this is a particularly great example of when one might want privacy, but it gives an example of people seeing transactions happening and being able to anticipate what's going on. And as the environment becomes a lot more professional, people are going to want to shield their transactions more and more. So you have some interesting companies coming into the space. John mentioned Aztec. There's also companies like Panther Protocol who solve the problem for DeFi by minting zero knowledge assets in place of the original assets, and then using those in shielded pools. There are different ways that you can use this technology, but privacy when transacting, I think, is a huge use case. Of course, you then run into, you mentioned regulation, you then run into a problem of, if you have private transactions, how do you make them compliant? Because obviously there's been, the whole crypto gets used by criminals things is, as we know, way overhyped. But you have regulators getting very twitchy in certain jurisdictions about Monero, about Zcash, whatever, because of private transactions. But interestingly, there can be ways to make these private transactions compliant. And that's when you get into the area of selective disclosure, which is what ZKPs are really, really useful for. So you would be able to have a computed audit trail that you could show the proof of a computation in such a way that a regulator or an auditor could validate that it had happened only in one particular way when it was decrypted, and provide only the information that you need to provide to only the parties that you want to provide it to. I think that's a particularly powerful case for them in the current setup.
Excellent. You guys touch upon a couple of the things that I wanted to highlight, which is, you know, zero knowledge proofs proves first that you could have these transactions with confidentiality, that you don't have, and second, you don't have to have that false trade-off between accountability and privacy. You can have both if you know, for instance, use zero knowledge proofs or some other methods that we can touch upon later. And then the third one is data minimization, right? Like not everything has to be stored on the blockchain, and so certain things, and you don't have to collect all the data all the time when it comes to computing things. And so to me, zero knowledge proofs addresses these three things from a privacy perspective, which I find fascinating. Thank you both for sharing some of the examples. If you guys don't mind, you know, sharing them in the chat, I know some folks would want to look into those further. That said, there are no silver bullets in privacy, and zero knowledge proof certainly isn't one. John, what are some of ZKP's privacy limitations in your opinion?
I think it's a great question. So one thing Rhian just mentioned about like front running. Front running is a big issue on public blockchains. The annualized cost of front running on Ethereum right now is around close to $1 billion a year. And that's just like, you know, value that disappears, taken from users and like going to miners or bots. Unfortunately, so one limitation of zero knowledge proofs is that it involves a single party proving something to another party. It does not allow for multiple parties to actually. So, for example, say there are you know, 5 shops in a zip code, and they want to find the average rent per square foot without revealing to each other what each store pays. That would require some sort of private computation that allows, like, you know, these folks to merge their data, do a privacy preserving computation on it, and then show everyone the average without having anyone share data with anyone else. The way this is different than Alice proving to Bob that she's over 21 is that it involves multiple parties and multiple inputs. So a problem like this cannot be solved by zero knowledge proofs, because zero knowledge proof only works with 2 actors. So as a result, it's like this front running problem is, as far as I'm aware, and I'm pretty sure, it cannot be really solved with zero knowledge proofs. Because, like, for example, front running takes place when there are trades, and as you know, if you're interacting with an order book, then you have to release your trade to the order book itself, and, like, you know, at that point, someone can front run. So I guess, like, the main limitation of zero knowledge proof is the fact that it only works between two parties, and on top of that, I think a limitation, not from a technical standpoint, but from a practical standpoint, especially in blockchain and the growth of the blockchain ecosystem, is ease of use. And by that I mean, like, coding something or building a zero knowledge proof system is immensely different than building a smart contract system like Solidity or, like, you know, as in other blockchains. Because when you're writing something in a smart contract, it is, you know, more or less similar to coding something like, you know, as in C+ or Java, like programming code. Whereas when you're coding something or when you're building something with zero knowledge proofs, you have to build mathematical circuits. So it's immensely different than, like, you know, coding the same function in a way people are used to do. And I think one limitation of that will be that like, blockchain ecosystems are as powerful as the developers behind it and the community behind it. Like, if we look at why Ethereum is killing it right now, is because it has a huge community very dedicated to growing Ethereum. I believe it will be very hard for zero knowledge systems to really, like, reach that developer mass that will allow these systems to grow.
I'd also add to this that there are, of course, Ethereum Layer 2 solutions that use zero knowledge as part of their architecture, and I think that's a really interesting thing, because again, it speaks back to the scalability thing that you were talking about before, because they're using if you're looking at ZK rollups, for example, they are providing that validation off the main chain that the main chain can then accept. And it's rather than building out a whole network from scratch, it's just a way that that can be validated on the main Ethereum blockchain rather than by a different protocol.
Thank you both for that. We mentioned a few applications, you know, and you guys shared some of them. Protocol, Tornado is another Ethereum crypto that is based on ZKP. What are other applications? And I know, John, you mentioned smart contracts, but are there other interesting applications up there of zero knowledge proofs in the blockchain that you're seeing that is worth looking into? And then as a follow-up, what other future, if there aren't any today, what do you foresee in the immediate future that might come up in this area? And then we'll jump into other types of privacy development in addition to ZKP after we touch upon this.
Yeah, as far as I'm aware, on Ethereum side, there's Aztec, which is a layer 2 that does shielded transactions. So you, like Alice, some funds to Bob, but like no one knows Alice is sending to whom and how much. I believe they have these transactions. Tornado does a mixer, which allows people to, you know, go from address A to address B with some sort of level of anonymity guarantees. Startware is releasing a new product called Cairo that is more for ZK scalability, and in this exchange, DYDX either is using them or has committed to use them, either one of the two. Honestly, those are the ones that I'm aware of on Ethereum.
Thank you, John. Rhian, anything else that you're seeing come up that are interesting to you, or others that you foresee will come up, other types of applications of ZKP on the blockchain?
Well, I have to say, I've been looking quite a lot at Aleo. I've been watching.
What is Aleo? Is it AL?
ALEO.
Oh, it's ALEO. Yeah, I saw that one. Yep.
Which I know very little about, except for having read a little bit about them and seen some interviews. But so that was just a tangent. One of the things I'm really interested in for the future is the use of ZKPs in identities, in decentralized identity systems. So I think that really is going to be one of the big stories of the future. If you look at things like decentralized gaming, decentralized virtual worlds, where people want to participate as an avatar, but prove that they are who they are without giving away a whole load of unnecessary information. There's a lot of interesting stuff happening around that at the moment in identity in general, especially when it comes to people's brands. Proving that your avatar is really you is kind of important when it's a person, but if it's somebody who is a celebrity who has a big brand, who wants to prove who they are in an entirely decentralized system, I think ZKPs are going to play an increasingly important part in the whole self-sovereign identity space. I think that's definitely a development that's worth watching.
Absolutely. I think that's worth watching out. I couldn't agree more, because from a social perspective, you know, we had this, as I mentioned earlier, the broader anonymity versus accountability debate that's going on in the blockchain. And to a certain extent, zero knowledge proofs allows us to get the benefits of both without, you know, having to have that being forced to have that false trade-off between privacy and accountability. So that part is certainly exciting to me. That said, we did talk about its limitations, right? The scalability, its use cases. So, and the fact that there are no silver bullets when it comes to privacy. So I want to broaden this conversation a bit beyond zero knowledge proofs. And John, what are some of the other privacy developments in the blockchain that you're seeing? And feel free to talk about some of your projects beyond zero knowledge proofs that you think is pretty exciting or worth looking out for.
Sure. So there are three main software-based private computation models. One is zero-knowledge proofs that we went over, and we discussed that zero-knowledge is between two actors, or like one actor proving something they know. And then there are two other that allows multiple parties to do secure computations, which is compute on data without seeing it in a privacy person. This is what Enigma, the company I'm a co-founder, had started as. It was a research project at MIT. And the idea is you, say you have some data that you want to work with. You divide that data into multiple pieces, let's say like, n pieces, and then send it to a network. And then if in the network, like, a threshold, say like n of m nodes come together and work on that data. I'm simplifying it a lot, but in a mathematical way, they can find the answer to that problem without revealing it. And this data can come from multiple parties. The whole idea is you divide it into multiple pieces, you send it to nodes, each one works on particular part of data, and there's a way in which you can bring all that parts together and reach the solution. What this helps with is none of the parties that gets exposed to some portion of the data is able to figure out what the whole data set is. One problem with MPC is it's slow, right? It's slow because every transaction or every computation needs to go in between nodes and stuff like that. And also there's a vulnerability where if the participants in the network that are doing this computation have a back channel and they communicate among each other and share that data, they can expose the data, and there's no way to provably make sure that this is not going to happen, right? So that's the problem with MPC, and the bigger you make the network, the slower the system gets. Like, just to give you some idea, when we were working on this in 2017, like if running a regression on like a plain data set takes like milliseconds, doing it with MPC would take like minutes, which, a million rows is nothing. So like if you try to expand it to larger use cases, it becomes a theoretical solution rather than a practical one. Another solution is, it's actually very much hyped. It's called homomorphic encryption, right? or fully homomorphic encryption. I'm not a crypto person, so I cannot get into the details, but it's as if, but I am going to share a blog post on the chat, which my co-founder, who is the researcher behind Enigma, wrote, so people who are interested can get in and read more about this. But homomorphic encryption is similar to sending data from multiple resources into a black box, and inside that there's some mathematical magic going on, which I cannot talk about right now, and you're able to get the results out. The problem with homomorphic encryption is it's extremely slow. And it doesn't scale to real-world production-ready use cases. So these are the software methods. And recently there has been progress in a hardware method called trusted execution environment. This is similar to, if you remember that you had a fingerprint in your iPhones or on your iPhones a couple of years ago. The idea behind that is your fingerprint goes to a chip, an enclave within the phone that is not accessible. And inside there, your fingerprint gets encrypted on the thing. Inside there, it get decrypted, and they can verify that like this fingerprints belong to you and unlock the screen. There are technologies by Intel and AMD that allows to do that for general computations. And the advantage of that is, while there is some, vendor trust that's involved, you can build things extremely fast this way, and you get to like 1/2 of the performance that you would work with like real life, like or plain text data. I'm a bit biased because we are building a blockchain solution based on TEs. And I can get into that.
It's really exciting. Yeah.
Yeah, I can
it's super exciting. Tell us more.
So so Secret Network is a layer 1 blockchain. based on Cosmos SDK, which is what we do differently is we require all validators in this proof of stake network to run nodes with trusted execution environments. And with that, we're able to actually separate the computation part and the consensus part on a blockchain. What that means is the following. There is a wide private key that is shared between all the enclaves. And because of this technology, a validator who's running the enclave cannot actually see what that key is and what's going on. And when a user wants to make a transaction, they basically request the network key from the network. There's some symmetric encryption going on there, which means that what the user gets is not actually the network key, but a symmetric key that the user can only use with their own private key. So I'm simplifying this because it gets a bit confusing. But the whole idea is, as a user, when I'm making a transaction, my inputs to the network are fully encrypted. So for example, if you're trading someone, no one can front run you because no one knows what you're sending to the network. And then this encrypted input can be taken by the validators, and they can decrypt its input inside their enclave. And they do the computation, which is a one-to-one function, which means if I get the same input every single time, it's a deterministic method. Gibberish data is shared on, and that's where consensus takes. So
thank you for sharing. Those are really fascinating. So you talked about homomorphic encryption and TEAS and SMPC. So thank you for that, John, and it's fascinating and it's exciting to hear that Enigma is also building in the TEAS space. So if you could share more information about that in the chat, that would be great. But I'd love to hear about what Rhian thinks when it comes to some of the privacy development she's seeing in the blockchain and crypto space, and if you have anything to add to that list of exciting things that you're seeing. Love to hear about those.
This is not exciting new tech because it's been around for a while, but I think when discussing privacy and crypto, it's probably worth dropping in. I think someone actually mentioned the dining cryptographer problem, but in the chat here. But yeah, could probably worth mentioning kind of more traditional techniques like Monero uses ring signatures, so otherwise known as the Where's Wally conundrum, because you, for example, you're using the principle that somebody in the room made a transaction, but you don't know who it is. And obviously there are lots of downsides and weaknesses to the idea of ring signatures, because you have to depend on the other participants to do things in the correct way so that they are not inadvertently revealing that they made or didn't make the transaction. But this idea of privacy through being in a crowd, I think it's not ZKPs strictly, but it's an interesting approach to privacy within crypto that obviously extends to things like mixers, as well as privacy coins like Monero.
I'm familiar with Monero, but I'm not as familiar with ring signatures. Do you mind telling us more, if you could share any sort of resources for the folks who might be interested in digging deeper into ring signatures? But yeah, certainly Monero and Zero and Zcash and all sorts of other crypto
it's
privacy coins out there.
It's interesting looking at these first generations of privacy coins, and although they are obviously using different technologies, Monero uses ring signatures, Zcash is ZKPs, deriving from a trusted setup, which at the time some people criticized the need to have this kind of trusted setup for the beginning of Zcash. But the way I see it, Zcash is good for doing particular things, but it's not programmable. So as you now have this whole ecosystem of smart contracts and DeFi, people can't actually use Zcash to participate in this. Because there has been this trade-off between programmability and privacy, which these new networks like Enigma, like Alio, like Panther, they're all doing this, going this, it's the new generation going a step further and enabling privacy in a programmable environment. I think that's probably the interesting overarching story to watch over the next year or two.
Yeah, absolutely. I know we're kind of running out of time, but I would love to hear your advice to our audience, which is primarily made up of privacy tech founders, investors, and domain experts, and how they could keep up to date on blockchain privacy developments, and where do you guys go? Like, where should they go? We try to bring together some, folks like you to our events, but if they wanted to dig deeper, where should they go to learn more about the privacy developments in blockchain and the crypto space?
It's really difficult question because you can obviously keep a general eye on developments using the normal crypto and fintech channels, but I think with ZKPs there comes a point where it just becomes so academic and so mathematical that unless you're a cryptographer, even if you're a sort of general purpose software engineer, I suppose I would subscribe to specific academic publications. But as I'm not a specialist in the area, I'm more of a crypto generalist, I just tend to follow interesting links about privacy and ZKPs that I find in publications like The Block and so on.
Thank you. John?
For me, there's a group called IC3, which involves researchers from the Zurich University, Cornell, Berkeley. They usually have the most cutting edge stuff that also applies to blockchain in terms of research. I am more interested in, move beyond the paper and research level and get to production level. And for me, mostly it's been, these projects, either like, you know about them because you know they're fundraising, or you read about those news, or like you've known them for a while. I honestly don't have like a newsletter or something of that sort that I use to get privacy news.
Yeah, no worries. I mean, we have plenty of privacy organizations and resources. I try to follow, the big crypto players. I listen up and follow Vitalik Buterin, obviously. There was that fascinating podcast that I mentioned earlier where they were talking about the latest in blockchain, and I'm happy to share a link to that in the chat, and particularly about ZKP and how they think it's the next wave of development in the blockchain space. But we are kind of running out of time. I would like to thank everyone, the speakers, obviously the audience, and the panelists for sharing their thoughts. If John and Rhian, if you have any closing thoughts that you'd like to share with the audience, please feel free to do so. Where can they find you? How can they connect with you after this? And again, thank you for your time and for sharing your ideas with us today.
Thank you for inviting me. I've enjoyed some of the other talks, actually. I've been dropping in and out of sessions during the day.
Perfect.
I'm at Rhian_is on Twitter. I'm mostly active there.
Thank you very much for looping me in as well. I'm also sharing my Twitter handle in the chat.
Thank you.
Yeah, I think I would like to finish by saying I think this concept of programmable privacy that Rhian mentioned is very exciting and huge for the next few years in blockchain. And really, like, the immediate value adds of this is not per se like privacy, but more so on usability. Because I don't usability problems such as front running is a bigger problem today in blockchains than the fact that everything is private, everything is public. That is going to change over time.
We certainly want both.
Yeah, I agree. But
yeah, we certainly want both.
So I think the immediate advantages of privacy will be on the usability side.
Right, and that we advocate for usability, privacy and usability types of solutions. And we just had like an excellent conference, not the Rise of Privacy Tech, but Pepper a couple of weeks ago, that addresses the design and usability, and how we can have both. So that's an excellent topic to end on. Thank you both for your time, and I hope you hang around and look at the other sessions. We did have, I think we finished the other blockchain session, and they talked about Hedera and some of the new developments. I know one of our advisors is also an advisor to Hedera, and so we also cover other decentralized tech solutions in the other session. So thank you all, and feel free to hang out, go to the main stage or network with folks. You should be able to do that on the left side of your screen. Sean, thank you again, and Rhian, thank you so much for your time. I really appreciate talking to you both, and I'm grateful for your time today. Thanks.
All right. Well, I'm going to jump off now. Have a great day, everyone. It was a pleasure meeting you.
Real
Pleasure to meet
pleasure.
you, John.
And thanks again, Lourdes. Thanks so much for asking me.
Bye, Rhian. Take care.
Bye.